Hello guys, this is Chris Fernandez. I was just doing a simple little video here to explain how I tested. I went through the four scenarios that we discussed, seen here on the screen, uh, going from 400 to 400 gig, 400 to 100 gig using PAM and NRZ on both scenarios here, and showing the 40 gig to 10 gig ports from NRZ to NRZ. So I'm gonna send this document along, and in this document I kind of show you what I did, how I did, and I want to just give you a little bit of a video here explaining what I did in IxExplorer 930 that I used for this document. Okay, so on the document you're gonna find the scenarios that we talked about and the products that I use, um, the cables that I used on all of them, and a little bit of traffic information that I did. So before I'll go on, so before I go on, I'll just gonna show you how you get the IxExplorer. The IxExplorer is a Windows-based application that comes free with the IXOS, and it's attached to our IXOS versions. So in our website, thekeysight.com, you go under support and you go to Exia product support, and then you go under software downloads, and we're looking for IXOS, and the version that is running currently on the Ares one is the 930. So I go to IXOS 930, and over here I pick Ares one, which is our platform, and you can get IxExplorer straight from here and download it and install it on your Windows PC. After you install it, you're gonna see you're gonna click on, and it comes up with a screen like this where you set the IP address of the chassis. So in my case, it's 10.80.81.24. Would you like to save the configuration so you can use it later? That's always a good idea. So I'm gonna do this, and under downloads, I'm gonna say temp demo. I'm gonna save that configuration, and it's gonna go in here and connect to the chassis. It turns green, so it was able to connect to the chassis. So first thing I like to do is go into multi-user here and log in. This gives me protection in terms of if I'm using two ports, for example, nobody can actually change the port speed or take the ports away from me. So after you log in, you create a login user. I'm gonna pick the speed for the ports that I want to go. So as you can see here, port 1 and 2 corresponds to resource group 1 and resource group 2. So there are 8 ports in the chassis and 4 groups. So each group has 2 ports. And when you change the speed, you're changing the speed for a particular group. So you can either change the speed by right-clicking here on the group itself. So I'm saying I want to change the group speed for those here, or you can do that via the web itself. So when you go into your chassis, under chassis, you can see here, this is my IP address for the chassis. And under overview, you're gonna see those four resource groups, and you can change the speed for the resource group over here. So this kind of gives you a little bit more information about what it's going to happen. So if, for example, if I pick 4 by 10 gig here, NRZ, it's going to create ports 11, 12, 21, and 22. Okay, so you kind of know what's going to happen after you change the speed. So for resource group 2, you can see that there are 8 ports inside here, and that's because 8 by 10, 8 by 100 PAM4 are selected here. So those ports, they're all running the same speed. So I'll go back to my resource group here. So the little example here that I want to do is I have a DAC cable connected from port 5 to port 7 in 400 gig mode. So I can see that those link is up. And first thing I would like to do is always take ownership for that port. So I'll take ownership for this port and I'll take ownership for port 7. After I take ownership, another thing that I like to do always is to run a tickle script to default the ports to the factory default. So I go into right click and I go into run tickle scripts and I say reboot CPU to factory defaults, and this is going to open up a tickle console here and execute a tickle code on that particular port. So you just wait a few minutes, a few seconds, and then you're gonna see here what it did. So it's just running the default script onto that port. And I'm gonna do the same thing for port 7. Just waiting to finish it off. After I finished it off, I'm ready to actually start my testing. So let's take a look at first what are my port properties here and what you can set under those ports. So general, talking about link. So if you want to do a test where it's an internal loopback, you just set it here. Anything that you set here, you just have to press apply. So preamble, link fault signaling, you can go through all those options as we follow along here. Flow control is enabled on the port. Transmit mode, this talks about the number of streams that we have. Auto negotiation, by default is disabled. Let me enable that. And as soon as I enable that, I'm expecting that port 7 will lose connection because auto negotiation is disabled on the other side, but I'll enable in here after I've gone through those the other tabs here. Things that you can do, insert FEC errors, lane skew mapping, and RX diagnosis. After I did that, I'm going to click apply, and this will reboot the port. Now I'm going to have the auto negotiation. Now it's now enabled on that port, and the port now has no more connection to port 7. So I'm going to go to port 7, go to properties, and I'm going to enable auto negotiation there too. So the link should come back up. Okay. So far so good. So all I did now is just getting the links up. And now I'm gonna send traffic from port 5 to port 7 at 100% line rate. So by default, there is already a stream, one stream per port associated to this port. So I'm gonna click on advanced streams, double click on it, and you can see here there's just one single stream already in a flow continuously, 64 byte packet at 100% line rate, which is 400 gig here, right? So you can go through the tabs here and see what is the settings already there. The DA, my MAC address, the destination and source MAC address, and if there's an IP address, there's no any other protocol on top of that. So if I double click on the stream itself, it opens up this screen here. That's where you can set things up. So you can see the preamble rate, the data. And one thing I would like to enable is instrumentation. Instrumentation is how we put in, how we measure time, latency, verify data integrity, CRC stuff, sequence checking. So I'm going to enable offsets here. I'm going to enable instrumentation and offset. And if you look at what it does, it put the signature placement. It's always this pattern here. So 87, 73, 67. After you enable that and you go back to packet view, you're going to see that after the MAC addresses, and the type, you're gonna see the 87, the 8773. This is our instrumentation now, starting right here. Okay, so and if you have multiple flows, you can go through them. But in this case here, nothing is going to change, so all my packets are the same. But if I have incrementing MAC addresses here or there, you should be able to go through the flows or the packet number as you can incrementing here. Go back to first and click OK. So now on the other side, which is my 7, I'm gonna have to look at my filters and the statistics modes, because I want to identify that instrumentation that I added to the packet. So I'm gonna go and click here, and I'm gonna click on receive mode, and sequence checking and data integrity is here. Automatic instrumentation is already signed, so he's looking for the same signature that we inserted in the packet over there. And we also looking at latency numbers and sequence numbers and data integrity. So all this stuff we're expecting to get from those packets. So right now I have set my stream to go from port 5 to port 7, and I enabled my views here. So my advanced stream here is not set. I'm not sending traffic back. I'm just sending traffic one way. So I'm disabling the traffic 7. So now I'm going to go into my global views. And I want to see the latency, right? So I'm going to delete this one that's already there. And I'm going to add a new one. And I'm looking latency on ports 5 and 7, even though I'm only sending traffic one direction. I'm adding 5 here, but I shouldn't see any. So this here is gonna see, I'm just gonna change the layout here so I can see the 2 ports. As you can see here, port 5 and port 7. These are the latency statistics. So I'm gonna enable that. And now I'm looking for statistics, but I don't have traffic running yet. So this should be nothing right now. So I'm gonna go statistics here, and I'm gonna delete whatever's there, and then I create a new one so you can see what I'm doing. Creating a new one, and again I'm gonna pick ports 5 and 7, and I'll add here so I can see the now the statistics for only ports 5 and 7. And I'm gonna set here timer. I'm gonna enable this, and I'm gonna say I want to send traffic for 30 seconds. Okay, so this is all I'm gonna do, 30 seconds of traffic. So I'm gonna say okay, and then I click start traffic. So as you can see here now, you're gonna see the statistics coming from ports 5 to port 7. Those are packets sent, packets received. They should match at the end, and I'm sending traffic for 30 seconds only. So after hits 30 seconds, this should stop. So over here is 19, 20 seconds, and you can see all the statistics here that are available for this test here, including the encoding that's happening, port speed. You should see 400 gig of layer 1 data rate. So traffic already stopped after 30 seconds right here. It stopped already, 30.07 seconds here that I transmitted. And when I look back at my latency view, right, I can see the latency now that was on port 7 only, right? So I'm transmitting one side only. So now that's about it that I want to show in this video. I want to keep it short, and I kind of to show exactly what I did on those documents. So for now, I'm gonna stop for now, and if you have any questions about what I did, how I did it, and if you want to learn more about the automation piece, we can take a closer look. But I don't want to make this video too long. All right, thank you. Bye.